These are the pH scale and acid-base calculation notes. In this video, we are going to focus on part one of these notes, which is the pH scale and calculating pH and pOH. So, describing acids and bases. So we've talked about things being acidic or basic, and so how do we do calculations with those? These solutions can be classified as acidic or basic or neutral, but we're focusing on acidic and basic. And that is based on the concentration of hydrogen ions that are in the solution. So acidic solutions have a greater concentration of hydrogen ions, which are H plus ions, than in water. Basic solutions have a lower concentration of those H plus ions than water. So the concentration of hydrogen ions is measured using the pH scale. So again, pH, potential of hydrogen, and this is used to easily express the strength of acids and bases. We use scientific notation when describing the ion concentrations. Again, square brackets means concentration, so H plus concentration for acids and bases, because their concentrations are always less than 1 and very, very small. And so when we're looking at this, because we are using these really small concentrations, that pH scale just, again, gives us a number that's a little bit easier to express and kind of gives us a little more context than a number that's times 10 to the negative whatever. So if we look at our pH scale over here, and with this here's H plus concentration. So something that's basic is going to have an H plus concentration of 10 to the negative 14. Those would be kind of that scientific notation part of it, or like 10 to the negative 10. So these are really small numbers. When we get to neutral, that's 10 to the negative 7, pure water. And so that's what we're comparing it to. So those concentrations of less than water make some H plus concentrations make something basic. And then water is that 10 to the negative 7 concentration. And then if we have concentrations that are of H pluses that are greater than that, that's classified as acidic. And so then that H plus concentration, because we're dealing with, especially if we get to things that are basic, or we get to things that are not so acidic, approaching neutral, those numbers get smaller. So our pH scale then is related to that, and we'll talk about how we do those calculations later in these notes. But that exponent, that negative exponent, the value of that, the positive value of that is related to that pH. So if we have something with 10 to the negative 10, it's going to have a pH of something that is around 10. It might be in the 9s, it might be in the 11s with that. And so we can see that relationship there. So we have the pH scale, but we also have a pOH scale. And remember, pH is potential of hydrogens. And so that pOH scale is similar. And so we most often use the pH scale when we're talking about acidity, and we can use it for talking about bases as well. And that's based on the concentration of our H plus ions. The pOH scale describes a solution based on the concentration of those OH hydroxide ions in a solution, and again, comparing it to water. So it works the same as this scale up here, and that pOH scale describes how basic a solution is. And so very similar to that pH scale, it's just pOH is we're talking about how basic is something, not how acidic is something. So pH, if you have a high concentration of H plus ions compared to water, you have a pH of 0 or a low number, so you have a lot of those H pluses. And then 7 is neutral water. If you have a low concentration of those H plus ions, then you have a high pH, so you are basic. And so if you have high H pluses, then it means you have low OH minuses. And so if something is acidic, it has low concentration of those OH ions with that. And so that pOH scale now is just like our pH scale, but now if we have a high OH concentration, it's going to give us a low pOH, and then vice versa. So these are just sort of inverse scales of one another. And these are related in that because these are both scales of 14, that pH plus pOH equal that 14. So if something has a pH of, let's say, 3, well, that means if it has a high concentration of those H pluses, a low concentration of the hydroxides, well, that's going to be over here with a pOH of something like 11. And those are going to add to that 14. So just pH is describing how acidic something is, pOH describing how basic it is. And so here is a summary of those concepts. It does have that OH concentration on there as well. Feel free to pause the video and read that for yourself. And so what formulas do we have? On your formula sheet, and these are on the back of your formula sheet, we have these formulas for our acid-base unit. So if we are doing calculations with those hydroxide ions, pH is calculated using your H plus concentration. So pH is equal to the negative log of that hydroxide ion concentration. The inverse of a logarithmic function is an exponential function. So to calculate the hydrogen ion concentration, we would do 10 to the power of negative pH. So that inverse of log. Our pOH and OH relationship are the same, but it's just pOH is equal to the negative log of that OH concentration. And then again, inverse of that logarithmic function is OH concentration is 10 to the negative pOH. So we can go between pOH and OH, but between pH and your hydrogen ion concentration. But how do we get between these two? Well, then we use that pH plus pOH is going to equal that 14. And 14 is an exact number. I've got 2 decimal places on this. But depending on how many sig figs you need, that 14 is exact. And so you kind of just use however many decimals your other values in the problem are giving you. So these are provided on the formula sheet. One thing to note, if you are getting practice or information somewhere else, maybe watching a video somewhere else, we're using H plus concentration, but you might see this H3O plus, the hydronium ion. Those are equivalent. It's just that for our purposes, I am going to use that. So if you see that other places, just know those are equivalent. This is just water with that H plus added because these are solutions, so there is water that is dissolving these ions. All right, and on our formula sheet on the back, notice this is that information that's there for you. So make sure you are using that as we are completing problems on this. That is the end of video 1. Come back or continue on to the next video for calculations on strong acids and bases.